Jai Bholenath student, my name is CHETAN VADHADIYA and today we are going to do a small quick revision, or you can say one short revision or mind map of chapter number 1 real number class 10 mathematics. So let us start without wasting much time. So from basic, let us start with some natural numbers. What are natural numbers? So we know natural numbers. Let me say the numbers starting from 1, 2, 3 up to infinity are natural numbers. What are whole numbers? Whole numbers. So you can say numbers starting from 0, 1, 2 up to infinity. All these are whole numbers. What are integers? So all the negative numbers from infinity to -2, -1, all the negative numbers, 0 and all positive number together forms integer. Now what are rational numbers? So rational numbers are actually the numbers which can be represented in the form of p by q, where q should not be equals to 0 and p and q are integers. Now why p and q should be integers, that is very important, guys. Actually when I say root 3 by 4, here you can say it is in the form of p by q and q not equal to 0. Still this is not a rational number because p is not an integer. So that's why you need to write down this, that p and q are integers. If you are not writing this, then your formula or your definition is half wrong, you can say. Now what are irrational numbers? Actually two definitions are there for this. You can say the numbers which cannot be written in the form of p by q, where q not equal to 0, are irrational number, or you can also say the numbers which are not rational are irrational number. But here for class 10 we are going to use the number which are not rational are automatically irrational number. That we are going to use. Why? Because for questions of prove that this will be useful, so we are going to do. Now the most important definition, what are real numbers? Actually what happened, in your NCERT textbook they had not clearly mentioned what is actually real numbers. We know that rational number, irrational number, or all this number together form real numbers, but one exact definition of real number is there, that is the numbers which can be represented on a number line, the number which we can represent on a number line are real numbers. So the number, any number that we can represent on a number line are real numbers. So all these numbers actually we can represent on a number line. That's why all these numbers are the real numbers. So this is the perfect definition, you can say. Okay guys, now let us go towards the questions, guys. Most important, you can say, the question that they are going to ask is this. Actually in this chapter, if you want to predict which type of questions are going to come, so I can directly tell you that one MCQ will be of HCF, LCF, or related to HCF, LCF. One MCQ will be there. So please do it properly, guys. So here we need to find out the HCF and LCM. So how we can do? Actually Euclid's division lemma is removed, so we are not going to use that. We have to find out the HCF of these two by prime factorization method only, right? So let us start with 2. First we need to find out the prime factor of these two. So 2, 1, 1 and 10, so 5 and 3. Now we cannot divide this with 2 now by 3. 3 5s are 15 and 1s are. Again we can divide this with 3. 3 1s are and 7s are, and 17 1s are. 17 is a prime number. So these are the prime factors of 306. Now similarly we need to find out the prime factors of 408, 2, 204, 2, 102, 2, 51, okay, and 3, 17 and 17 1, you can see. So these are the prime factors of 408, So for HCF and LCM, first for HCF, you need to see the common terms in both this. 2 in common, now here 3, here also 1 3 common, and 17, here also 17. So HCF will be equals to 2 into 3 into 17. The numbers which are common in these two, that we need to multiply. So 6 into 17. So 6 7s are 42, 4 carry, 6 1s are 6 plus 4, 102 is your HCF. Now, how to find out LCM? For LCM, what you need to do, you just need to write down the number which are common first of all, 2 into 3 into 17. Now you need to take the remaining terms also. 1 3 is there, this remaining 2 is also there, this remaining 2 is also there. So now we need to multiply. Actually here we know multiplication of this 3 is 102 and multiplication of this 2 2s are 4 3s are 12. Now we need to multiply this. 12 2s are 24 and 12 1s are 12. So this is the answer, guys. This is your LCM. So this way easily you can find out HCF or LCM, guys. Now one question related to one of the, you can say, equation they had given, that HCF into LCM or the product of HCF and LCM is always equals to the product of that two number, first number into second. This is the equation. So with this equation, if any three of the terms are given to you, you can find out the fourth one. So here they had given us that the HCF of these two terms is 9 and we need to find out the LCM. So directly by keeping whatever given to us in this, we can find out the answer. How? HCF. So HCF is 9 into LCM, that we need to find out. First number, here these two are the numbers. So 306 into second number is 657. Now take this 9 in the denominator. LCM equals to, here it is in multiplication, so on this side this will go in division. 9, so 3 3s are 3102. Again we can cancel this. Yes, 3 1s are 3 3s are 9 and 4s are 34. Now we need to multiply this 657 into 34. So 0 7 3s are 21, 2 carry, 15 16 17 carry 1, 18 and 19, 4 7s are 7 4s are 28, 2 carry, 5 4s are 20, 20 plus 2 22, 2 carry, 6 4s are 24, 25 26 and 8 3 6 12 13 carry 1, 9 10 12 carry 1. So 2 2 2 3 3 8, 2 2 3 3 8, or you can say 22,338 is your LCM, guys. So this way you can go with the answer. And moving towards the next question, guys. Now one of the most important things, they are going to ask this word problems for 1 or 2 marks. So I think 1 mark MCQs there. So they are going to ask this for 2 mark or 3 marks. Actually here one big, you can say, big confusion is there, when to find out HCF and when to find out LCM. So that you need to understand from the question. I'm going to give you the hint also. I have made many videos for that and I have explained when to use HCF LCM in my previous videos also. If you had not seen that, you watch that also. Now also I am explaining that quickly. So here you can say an army contingent of 616 members is to march behind a band of 32 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? So two groups are there and they have to march in the same number of columns. So can you tell me the number of column will be greater than 32 or 606 or greater than 32 or less than that? Actually, if they have to march in column, that lines, they have to march in lines, so that line will be less than 32. They cannot make 33 lines for walking. Why? Because these members are 32 only if they are going. So whenever your answer will be less than this two or same as itself. That you need to understand by question. Here we know that the numbers of lines cannot be greater than 32. Less than 32 or line can be equal to 32. So at that point of time you need to find out HCF. If you are getting that the number of lines should be more than 32, then LCM. That we will understand in our next question, but here we need to find out the HCF of this two. So I'm not going to solve, but I am directly telling you, just you need to find out the prime factor of this two and find out the common as we had done earlier. Okay, moving towards the next question. You can see there is a circular path around a sports field. A sports field is there, circular path. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point. They both start from this point, suppose, at the same time and go in the same direction. They both go in the same direction. After how many minutes will they meet again at the starting point? After how many minutes they will meet again at the starting point? So here what happened? 18 minutes Sonia started and completed in 18 minutes. Ravi takes only 12. So Ravi will run faster than Sonia. So will they meet in 12 minutes or less than that? No, not possible. They will not meet in less than 12 minutes. So your answer will be greater than 12 or greater than 18 also. So here we know that in 12 or 18 minutes they are not going to meet. So they will meet after 18 or time will be more than that. So we know that. So directly we need to find out the LCM, guys. So here we need to find out the LCM of this two. So find out the prime factor of this two, and then I explained in previous video the same way you need to find out the LCM. Okay, find out by yourself, guys, because we are going to learn new thing, guys. Now this question is that prove that root 3 is an irrational number. So for this, guys, first of all you need to understand what are irrational number. I explained in our previous part also, the numbers which are not rational are irrational, right, guys? So actually two types of numbers are irrational. Which are they? One, terms with root sign, but root sign whose root we cannot take out, whose root we cannot find out directly, whose root we cannot find out directly. Like, let me give you example. Root 2 is irrational. We cannot directly find out its root. Root 3 is also irrational. But root 4 is equals to 2. We know root 5, root 6, root 9 is 3. Root 16 is 4. So here we can directly find out the roots of this term. So these are not irrational. These are rational. These three are rational. But other than that, all are irrational. First, this irrational. The second type of terms are non-terminating, which are irrational. Non-terminating, non-repeating numbers are also irrational. Let me tell you. If I tell you to divide 17 by 5, if you will divide this 17 by 5, what answer will you get? 3 5s are 5 3s are 15 and 2 zeros, so 3.4. Further you cannot divide. Let me do it here. 5 3s are 15. Now 2 decimal we need to go. Now 5 4s are 20. Now you can see here we got remainder 0. We cannot further divide this. So this type of number whose division stop after few points, they are called terminating numbers. They are called terminating number. Terminating numbers are rational. Now if I tell you divide 10 by 3, so here you will get 3.333333. Try to divide by yourself. Here you will get like this 333. This will not stop. So this type of numbers are called non-terminating numbers. But here you can see every time you are getting 3 only, 3 3 3 3. So this is non-terminating repeating, non-terminating repeating. So all non-terminating repeating are also rational number. But sometimes I am not giving you example directly. I am writing 3 4 7 1 4 7 1 0 4 7 1 0 0. This way you can see 471, then 4710, 47100, and this way it will go on. So this type of number which are non-terminating and non-repeating also, non-repeating also, this type of numbers are irrational. They are irrational. So this type of number are irrational. And terms with root are also these two type of number, this and this. These two type of numbers are irrational. All other are rational. Okay. Now, as I told you that we don't have any perfect definition for irrational number, but we know that the numbers which are not rational are automatically irrational numbers. So here we can do that. How? Suppose directly we cannot prove this as irrational number. So what we are going to do? We are going to first of all suppose this as rational number and find mistake. So if this will not become rational, so if it is not a rational number, we can say that is irrational. So let us start. Suppose root 3 is a rational number. Suppose root 3, let me write down, is a rational number. First we need to suppose. And if it is a rational number, therefore what we can say, root 3 can be written as a by b. Now can I, root 3 can be written as, now take it here, root 3b is equals to a, squaring both the side, squaring both the side. Why we are doing squaring? To remove this root sign, squaring both this side. So this will become 3b square is equals to a square. Now these two are equal. Here 3 is there. So somewhere inside this a, one 3 is there. So we can say that therefore a square is divisible by 3. But one thing we forgot to, here we need to suppose root 3 is equals to a by b, where a and b are co-prime. Co-prime means that type of number that numbers don't have any common factor. Here these two numbers don't have any common factor. Let me tell you how. Suppose if I am telling you 6 by 8, are this number co-prime? No. We can cancel this and reduce. How? 2 3s are 2 4s are, so 3 by 4. Now you can see, now further we cannot cancel this. So these are co-prime numbers. They don't have any common factors. Okay, like 5 by 7. These are co-prime because we cannot cancel, or you can say these two numbers don't have any common factor. Okay, so these are co-prime numbers. So we have to suppose these two are co-prime. Now here we got that a square is divisible by 3. Therefore we can say that a is also divisible. If square is divisible by 3, then without square also that number is divisible by 3 by theorem, or you can take this as result number 1. Now inside this a, a is divisible by 3. So inside this a, some 3 is there and some other number is there, right? Because 3 and some other number is there. So suppose a is divisible by 3. So we can suppose that a is equals to 3c. A is equals to 3c. Now keep it here. 3b square is equals to 3c whole square. Now 3b square is equals to whole square is there. So 9c square. Now take this 3 here. B square is equals to 9c square by 3. 3 1s are, 3 3s are. B square is equals to 3c square. Now here you can see, here in 3 is, these two are equal and 3 is on the right hand side. So somewhere inside this b also 1 3 is there because both are equal. So you can write down therefore b square is also divisible by 3, and therefore b is also divisible by 3. Take this as result number 2. From 1 and 2, what we got? A is divisible by 3, B is also divisible by 3. Therefore, we got A, and therefore from 1 and 2, you need to write down everything from 1 and 2. You can check your NCERT how to write down. I just want to explain the concept. From 1 and 2, we can say that A and B is having common factor 3. Common factor 3. But this contradict our supposition. That what was our supposition? That A and B are co-prime number. But here we are getting common factor. But this contradict our supposition. So this contradiction has arisen. This contradiction has arisen due to our incorrect assumption. What was our incorrect assumption? This contradiction has arisen due to our incorrect assumption that root 3 is rational. Our assumption become wrong, that root 3 is rational. That is wrong. So automatically, what will happen? Automatically we can say if root 3 is not rational, therefore we can say that root 3 is an irrational number, guys. So this statement you need to check from your NCERT textbook, because this statement is a little bit long and you have to write down same as it is given in your NCERT textbook. So please follow that, guys. And many more extra important questions of this chapter also I had uploaded, guys, before earlier also. You can watch my that videos also. I will try to give you link in the description, and if possible you can also search important questions of rational number by Galaxy coaching classes. So obviously you will get that in your search bar also, guys. So thank you so much for watching my video. If you like it, please subscribe to my channel, guys. Thanks. Jai Bholenath. All the students of India, USA, Canada, UK, Australia and other countries can join me for more videos.